Yes, hello, good morning, Lauren. Um, Today, what I'm going to do now this morning is I'm going to walk through a few of the questions that you've been asking about. I'm going to go and do a full example of a few of them and narrate it while I'm going. Hopefully, this will introduce the topics in a way that's a bit more understandable, maybe than writing it out. I do think what I've written out is fairly comprehensive, but I can understand that math isn't something that we always, you know, learn through reading a paragraph, written out in text. It can make a lot more sense to see it actually done. So here today now, what I'm going to do in this video is I'm going to show you an example of a few of the different ones that you're doing. That way you can follow along when you're doing them yourself, and I'll just show you all the different steps, right? You mentioned that you had some other people who have shown you how to do some of this stuff. That's totally fine. Just do be careful when they're doing it, that because they might not be aware of what you've done so far or what you're going to be doing in the end. I would recommend, because like my job here is to basically be a tutor for you as well, right? So I should be the first stop, basically, is kind of what I'm saying. And don't worry about like if you're, asking too many questions or whatever. That is what I'm here to do, right? Is to answer the questions on these things. So while other people can be good to help you, of course, right? I'm not saying don't ask your friends or your family or whatever, but they might not know, what you've done so far and what you're going to be doing next and all that kind of stuff. So from a teaching standpoint, it does make the most sense to come to me first, basically, right? But anyway, um, I am now going to. I'm trying to find a straight edge here, actually. Hold on. Oh well, I'll use this same card that I've been using. Yeah, so I'm going to go down through some examples out of these sheets. Now, these sheets are actually pretty logically arranged in that worksheet 1 flows into worksheet 2, flows into worksheet 3. So it's good to get worksheet 1 out of the way first before we move on. So the first thing I'm going to do here today now is this first topic, which we see, actually my cursor is very small on this screen. You can barely see it. Oh, hold up. Hold up. What the heck? Every time I click, it goes to another page. All right, okay. Well, I'll figure out the issues with Foxit Phantom PDF in a moment. But for right now, I'm going to do one of these ones here. Let's say I was to do C. I'll start off with this. So I'll do the number 96 as a product of its primes. Okay? So this is going to be math 1101A. Unit 3. Oh, bear with me just a quick second here. I'm going to. It's a little annoying when this happens, but I'm going to try to do the focus manually for my camera here, so I'm not having this thing where I've got to try to move my hand back and forth to get it to refocus on the depth of the paper. Anyway, okay, I think I'm okay now. So unit 3, and this is going to be worksheet. This is now worksheet number 1, and I'm going to do 1C. Now I know that this was one that you've already got done. I'm just going to start here to show you how to do these, so then I can move on and show you one from the next questions as well, and it'll show how they feed one into another. So first up, we've got the number 96. Now in prime factorization, what that means is we're going to be looking to see how many times we can divide this number, 96, by a prime number. Now, of course, to know that, you've got to know what a prime number is. A prime number is any number that can only evenly be divided by itself and 1. Okay, so there are a lot of different prime numbers, but based on that description, you will know that every prime number has to be odd except for 2. Except for the number 2. Why is that? Why is 2 the only even prime number? Well, every other even number we know can be divided by 2, right? So the easiest thing to do every single time we have one of these questions is to divide by 2 until we get an odd number. And only then do we actually need to start sort of doing the harder work of looking through which other prime numbers could go into it, right? So 96, well, I know half of 96 is going to be 48, right? So we can break this off into 2 times 48. Now I use the dot to represent multiplication. That's just a notation you'll see later on. What we're going to do here now, every time we get to a prime number, that's going to be the end of that branch or that part of the tree, right? And then we're going to keep moving on down over here. Now 48 is still an even number, of course, because it ends in 8. So I'm going to move off down here, and that's going to be 2 times 24. Hey, look at that. That's another even number, right? I'm going to keep branching off until I don't get an even number anymore. 2 times 12. Hey, look at that. That's easy. And this is going to break off into 2 times 6. That was a super easy one. Now 6, again, is an even number. 2 times 3. Okay? What some people will recommend you to do is that when you reach a prime number, you circle it, like so. Then what we're going to do in the end, to map out what these are, we're going to write down all these numbers next to each other. So what we're going to say is 96 equals 2 times 2 times 2 times 2 times 2 times 3. That's sort of in a longer form. And now we can use exponents. We can say 96 equals, well, how many 2's is that? That is 1, 2, 3, 4, 5 2's. So it's written as 2 to the power of 5. Now, I'm not sure which of these parts you understand and which parts you don't, right? This is extremely important to understand what this means here. Now, the exponent, 2 to the power of 5, this 5 in the corner means that it's 5 2's multiplied together, right? It's not 2 times 5 or anything like that. It's 2 multiplied by itself 5 times. So 96 is 2 to the power of 5 times 3. Swig of tea there to... Anyway. So, yeah, 1C was maybe not quite as difficult as I'd hoped. Let's go on to... I'll keep doing a few of these. You did question 1 fairly well, so I don't mind showing you more of these. And this is a worksheet. This one's kind of for marks. The worksheets are sort of like a middle ground between assignments and work from your text. So I will go through a lot of these ones. Let's do 250 now. 250 is one where we get another property, right? So like this one here showed it, basically every single time we're going to be dividing by 2 as often as we can, right? Another thing we can do is if a number ends in a 0 or a 5, if a number ends in a 5, we know we can divide it by 5, right? Because that's how base 10 works. You know, of course, you know, the multiples of 5, 5, 10, 15, 20, 25, 30, they always end in a 5 or a 0. And if something ends in a 0, we know we can divide it by 10, right? So here I could choose to divide this number by 5 or by 10. I could also do by 2, right? I could call this 2 times 125. I totally could, in keeping with this rule over here, right? So there's a few different ways we could go about doing this. I'll show you the 2 times 125, right? Because in keeping with what I said over here, you can always divide by 2's until you get an odd number. Now we've got an odd number, but it's an odd number that ends in a 5. And if an odd number ends in a 5, that one's easy, right? Because if it ends in 5, we know we can divide it by 5. So 125 is going to be 5 times 25. And now 25 again is a number that ends in a 5. So we know this, and we know we should have memorized, right? 25 is 5 times 5. So we can get that. Or we could easily, just as easily, do something like this, right? We could say 250 is going to be 10 times 25. Because we needn't break off, you notice over here and over here, each time I was breaking off one prime number. Personally, I find that's the easiest way to do it, but you don't need to. You could break it into 2 non-primes that you know multiply together to make the number. Like here, I know that 250 is 10 times 25, right? Because it ends in a 0. And if a number ends in a 0, I know I can evenly divide it by 10. Now, if we have a situation like this, I can keep breaking down both of them, right? I know 10 is going to be 2 times 5. Both those numbers are prime. And 25 is going to be 5 times 5. But in either situation, we end up with the same result. 250 equals 2 times 5 times 5 times 5, or 250 equals 2 times 5 to the power of 3. Okay? And this is sort of the way that we will start doing these, excuse me, the way we will start doing these questions. Now, to flick back over to our worksheet for a second, the next question, prime factorize each of the following and write your answers as a product of primes with powers. That's exactly what I'm doing. Oh, product of primes and product of primes with powers. Okay, let me just explain that for a brief second. So question 1, rate each number as a product of primes. That would be, let me turn this on so we can see it, have it up there in the corner. So question 1's answer would be like this, right? Question 2's answer would be like this. The workings to get to this point are exactly the same. There's hardly any difference between those two questions 1 and 2. Just in questions 1, they're looking for you to give the answer like this. Question 2, they're looking for you to give the answer like that. If you gave the answer like this in question 1, I would mark that right as well. Like, I'm not super concerned if you just don't put it into exponent form. Whatever. Right? To me, this is the right answer in question 1 and 2. But the working is exactly the same. But the next thing I want to get onto is questions 3 and 4 over here, because I know you mentioned a little bit of trouble with some of these. I can understand how they seem a bit more difficult from the start, but once we get into it and break it down a bit, you'll see that these are actually, turns out, pretty similar to those last few, right? So let me bounce back on over here. So for question 3, so this is going to be math, still math 1101A, unit 3, worksheet 1. Right, and now we're going to be looking at, let's do one of the ones with 2, and then one of the ones with 3, and then, yeah, so we'll do 4 different ones here for these. And since I'm linking this to you as a video, you can move easily between one section and the next. So, I'm going to do, we'll do questions 3 and 4 here from this sheet, parts of them. So, 3, let's start off with, I'll just do 3A for the first one. So, we've got to find the greatest common factor of each set of numbers. Now, first up, the way we're going to find the greatest common factor, now it does here just say find the GCF, right? So I can understand the way you did it on the sheet, which was the way that you've seen before, but that's not the way that we're taught in this unit, and that's not the way that we're going to do it on this activity, right? We're going to keep using, it should have said determine the GCF of each set of numbers using prime factor decomposition, but it didn't spell it out like that. But that is the way that we're going to go about these, is using prime factor decomposition. But once we start using prime factor decomposition, it's actually quite a lot easier to find the GCF and LCM of numbers that are otherwise prohibitive to do that with. All right, but the first thing we're going to do is we're going to take 46 and we're going to break this down into its prime factors. So it's going to be 2 times 23, and then we're actually done. We're actually done there at 2 times 23, because 23, I know, is a prime number. Now you can always go back and try, right? You could say, well, 46, if I divide that by 3, but that gives you, 46 can't evenly divide by 3, because 45 evenly divides by 3, so it doesn't work for 3, doesn't work for 5, doesn't work for 7. It doesn't work for 11, because 44 works for 11. It doesn't work for 13. So actually, 46, it's just 2 times 23. It's a bit inelegant, but that is what it is. Right? Now 84, so I could say down here 46 equals 2 times 23. 84 is going to be 2 times 42. 42 is 2 times 21. And 21, as we know from our times tables, is 3 times 7. And both of those are prime as well. So I now have 84 is going to equal 2 squared times 3 times 7. Right? Because there's two 2's, which is the 2 squared, and there's a 3, and then there's a 7. So now what we can do is we can find the greatest common factor. The way we can find the greatest common factor here, we have to see what's in common. All the different numbers in common, we take those and we multiply them together, right? So in 46, we have a 2 and a 23. In 84, we have two 2's, a 3, and a 7. So all that's in common is just a 2. So the GCF, greatest common factor, is simply the number 2. All right, that one was maybe a bit small of a one to start off with to show how this works. But that is all we've got to do is just find, first we break them down into prime factors, and then we find what's in common between them, and then that's our GCF. Right? So say I did question D. So question D is it has 96, 48, and 36. Let me remove this other window here. So we've got 96. I'll take this one and break this one down. Now 96. Wait a minute. Are those the exact same ones we did on the previous page? Oh no, I did 96 on the previous page. Yes. So we know that 96 is. I'll just do it again from the start here. 2 times 48, which is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So we now know that 96 is equal to 1, 2, 3, 4, 5 2's. So that's 2 to the power of 5 times 3. Okay, we're going to do the same thing now for, 48 is already a factor of Well, anyway, that doesn't actually matter. It doesn't actually matter. It'll work out the same. It's still a good example. So it's going to be 2 times 24. It's a little bit annoying as far as demonstration sake goes because it's exactly the same as this section over here, but not a huge deal. So 48 is going to equal 1, 2, 3, 4 2's. That's 2 to the power of 4 times 3. Okay? And now 36. You might know that 36 is 6 times 6. You might know that off the top of your head. But I'm going to keep doing the dividing by 2 each time. Again, right, this is just a recommendation to divide by 2 each time. You don't have to. Because you'll get to the same thing in the end anyway. If I broke it down 36 into 6 times 6, 6 is of course 2 times 3, we would end up with the exact same result. So 36 is equal to 2 squared times 3 squared, like so. Excuse me, my allergies are going bonkers today. Oh my goodness. So now I have to find what's in common in all 3 of these, right? Not just ones that are common between 2, but numbers that are common between all 3. So we have 5 2's here, we have 4 2's here, and we have 2 2's here. So what's in common? What's the biggest, what I'm saying is, what's the biggest number of 2's that's present in all of these numbers? Well, it's 2 of them, right? Because there's 2 2's here, 4 2's here, 5 2's here. So there's at least 2 2's in each of these. So in finding our GCF, I'm going to use 2 to the power of 2, or 2 squared. And there's 1 3 here, there's 1 3 here, and there's 2 3s here. So there's 1 3 in common amongst all of them as well. So our GCF then is going to equal 2 squared times 3. 2 squared is 4. 4 times 3 is 12. The greatest common factor is 12. We can't actually see that from our trees here because I didn't break these down in a way where 12 came out over here. I could have from the start called this 3 times 12, and then it would have been more obvious because we would have had a 12 here, a 12 here, and a 12 over here. But that's not the way we do it, right? Because as we see here, this what I did was totally 100% completely valid, but I don't have a 12 in this table, so I wouldn't have noticed that 12 was the GCF without actually following through and doing the full workings. Okay, now I'm going to pause the video for a second here to help another student for a second, and then I'll be back and do an LCM example.